G'day guys, it's Calvin from the Cartoon Company. I do a heap of 1UZ conversions and wiring, and today we're going to talk about a wiring loom I'm making for a car in Australia. It's using a LINK Extreme. I've got the old loom in front of me and it is a complete mess. We'll have a bit of a look. The customer sent me photos of this one and it looked pretty disgusting. It's ended up on my workbench to be sorted and I'm starting the process. So one of the first things I do is I go through and I check the loom. I download the data out of the ECU, download the profile and work out where all the wires go. This is the loom. This is the loom going to the knock sensors. I have popped that plug off, so that did actually have a plug on it. That one had silicon in the back of it. That isn't actually too bad. Here is the bare wires on the starter motor. Now you might say that that's really bad, but that isn't too bad. It's going to get worse. This is the front crank loom. Those are the plugs. Coil plug, crank angle sensor plug. So that's probably not going to be so good. In the main loom, terminals pulling out. I had to just sit them back in so I didn't short things out. Alternator, wiring with an adapter plugged in. Sort of ran across. And then there was this thing, which turns out the battery light, or the alternator light, mounted under the bonnet. It's not looking good. This is the earth for the whole system. For the ECU, doesn't go to the block, it actually goes to the guard. Not ideal. Now I will let you know that I have taken some tape off here, just a little bit. We have this wire here. Comes in, it's a black red wire, comes down into this piece of red blue. Comes over here and goes into 1, 2, 3, 4 red wires. That is the power supply for the coils, the injectors, the igniters, and the ECU. All of them are on that one wire. Black, red. Oh, no. Red, black. Pretty common on Toyota, that's a reverse. Sure enough, if we come over to the back here, plug going down, looks like a gearbox to a plug down there. So that's reverse lights. And a power feed for the reverse lights, which also goes off to the alternator. So that's the 3 wires in that one plug. A start wire and a permanent battery power. These ones tried to have me fooled. They looped around. That's the start inhibitor. I was checking for continuity elsewhere in the loom and like, where do these go? Oh, of course they go to themselves. So that was pretty straightforward. I have a crank angle sensor that's broken and actually doesn't test very well. That's going in the rubbish. I have a cam angle sensor. I'm going to put that in the engine and run it and see what it looks like. Just looking at it, even if it tests okay, I'm often tempted to replace them just to be on the safe side. We have a couple extra wires just sort of randomly leaving the loom. Those are oxygen sensors, I think. They weren't turned on in the ECU. Fuel pump trigger. Fans and a tacho over here. That's not the fan, that's the tacho wire there. And there was a fan wire here somewhere. That moment that you're not actually sure where the fan output is. There it is. There's the fan output. Map sensor. All wires falling out, broken, twisted. Like, this is never going to work. There's bare wires in there. There's wires that are just about broken. So I had to come up with a plan. With the power feed going in the way it is and looking at the profile, the idle stepper was never going to be right. And quick chat to the mechanic who's working on it. And I've got to remember here, this video will be made and shown to the customer, who is the mechanic, and the owner of the car, who is his customer, probably before everyone else sees it. It's also going to serve as the instructions. But looking at the idle, I had a chat to Shane, the mechanic, and he said it idled like crap. It was horrible. It wasn't nice. Had the factory stepper motor on it. Was set up in the computer on an open loop setup. It was never going to self-adjust. Just what that number of steps resulted in was the idle. And the way it was set is if you had to turn it off and quickly turn it back on and started it straight away, the idle could have done very weird things. So that was going to be a problem. I'm going to eliminate the factory stepper on this one, and I'm fitting an aftermarket 2-wire stepper. So that's nice and simple. I am going to fit an oil pressure sensor to the ECU. So the ECU will see that, and that will control the outputs. Like an oil light on the dash. I will do a pair of normal knock sensors. I'll upgrade the knock sensors to the later model one, the more common ones. And I've already made a knock sensor loop. So we went from this loom to this loom. I was about to put a couple of zip ties on there. So that's quite a difference. With regard to oxygen sensors, I'm not actually going to bother with it on this one. I'm going to put in a plug for later on so it can have a wideband sensor fitted, little wideband control unit. The G4 Link Extreme won't take the CAN Lambda like the G4 Plus. And so that's a good solution. I prefer them over narrow bands, better tuning range, much more functionality. We can set up proper logging, and I'll probably set up logging before this one goes home. So we can download log files. I can have a look at them over here. What else am I going to do? Build a new loom. Make it nice, make it proper. You know, I could actually have a search in here and see how many joins we had, and I bet you it wouldn't be pretty. I'm not going to. It looks like they've recycled second-hand plugs, maybe. So there's that plug. That's an injector plug. That's an injector plug. There was a different one somewhere else. Over here. Oh, the igniters. Oh, the igniters. Oh, igniters. I'm throwing those away. Here's another injector plug. Different kind again. And you can see the terminals are pulled all the way back, so that's not going to work. It's also getting individual coils. So that's, you know, we get a car, you look at these older UZs, they need a set of leads, they need a set of distributor caps, they need a set of rotors. The coils are suspicious and likely to give trouble. So why not do a coil on plug while I'm rewiring it? It's about the same. Not far different between buying those components and putting a set of individual coils when I have to rewire it anyway. So that's going to happen as well. Temperature sensor, I'm going to put a normal one in it and make a, as I said, make a nice loom. I've already mapped this one out. I've got the profile out of the computer. I'm not using any of that loom. Zero, Zippo, nothing. Will I use these plugs? I might use the plugs going into these couple of plugs. Apart from that, I'm not using any of it. So I'm going to prepare this engine. I've just wired a coil on plug loom on old yellow here. So I've just taken the bits of manifold off. I'm not sure I'm ever going to get to edit that video, but that's the bits of manifold I was running on old yellow. It's kind of looked funny with you know something's up when there's not much manifold, eh? So that one wasn't quite normal. I made the knock sensor loom first so I can put the manifold on it and continue with the wiring. So I'm into it, and we'll give you a bit of an update as we go through. I'll show a bit of the process. At some point I will get around to doing a proper step-by-step instruction on wiring these. I will do one on a more normal engine running just the leads for a start. There'll still be lots of information in here that'll be helpful. It'll still be kind of instruction-ish. It'll show the process, and it'll show some of the setup of the ECU and the issues that we face. So, work time. I'll talk to you soon. So a little bit of time has progressed on, and we've got some wires going onto a loom. So we've got some wires happening there, laying out the cam and crank wires. And on this side, I'm into the covering already. So no new temp sensor and plug for the dash gauge, and I know it's got an aftermarket gauge in it, but by putting this unit here on, it means that if it does need a little extension, we can just build a little extension when it's fitted up. So that's really simple to do. And I'm starting to put some plugs on. So that's nice and neat and tidy, and this will come along pretty good. Set the coils in. We've got to cut some legs off it in a minute. So we pretty much just cut off. I actually cut into where the steel insert is, and then I linish it off and make it look nice and neat and tidy, and they sit into place quite nicely. They are a 3UZ coil. Now the reason I use a 3UZ coil is, one, I work on lots of 3UZs, so it means I can keep the 3UZ coil in stock, and it does two jobs. They're readily available, and it keeps it nice and simple, and they're really well priced over here. Different markets, different coils, the principle is the same, and I really recommend using something that is available in your market. So, more wiring for me. I'll talk to you again soon. When you're wiring up these engines, it's important to know what the sensors actually are. This is the EFI temp sensor that goes back to the computer. Polarity of the wires does not matter. This is the one for the gauge. So that's the temp sensor for the gauge. If there's one here, it's the cold start injector timer. This one doesn't have it. We're not using it. You can see there's a 2-wire idle speed on this one. Injectors. Polarity is not important. I'm about to do the throttle position sensor. We'll run through the wiring on that. And we'll run through the wiring on these coils. Air temp sensor, which is going to go in the back of the throttle body. Polarity is not important. Map sensor. I'm using a LINK one on this one. I'm swapping out from the GM one, which I don't really like, and I can't test because it's not here. These are specific. It has a 5 volt, a signal, and a ground. Really neat because I got the Deutsch plug on them. Good to work with. Running the LINK, I only use the left hand cam sensor, and I must put his one into it, the customer's one into that one. Here I have a TPS plug. Here's the new one that I'm going to be using. This is the same for all of the non-VVti TPSs. So we have a brown wire on the end. I'm using a black-orange. It's in pin 1, so that's the earth, goes back to the ECU. I'm going to call it 0 volt, and I'm going to put the wire in the right way. No, I'm not. Here it is. So this end I'm going to call that 0 volt, so it's going back to my sensor earth on the link. I've got the one beside this, the ground, or the 0 volt, is your idle switch. And I'm actually going to be running the idle switch back to the ECU. Then you have the sensor itself, that's the actual TPS signal, and then you have your 5 volt supply. On the Toyota, generally, it's blue-red. This one, I'm using a pink-orange, and that's my same colour on all of mine that I use for my 5 volt. And there's the TPS wiring done. Really simple, all non-VVTIs, that will work. Removing the cam sensor, trigger, assembly, also holds the distributor cap. So that's my one coming off. And I fitted up the replacement one into a cut down housing with all the extra stuff gone. It's not necessary to actually take all that off, but I think it just looks neater and tidier. A lot less in there. And I've still got the bolt hole for the front cover to go on. So this can go back in. That way I'm testing the customer's parts to know that they are working and like they should. And this morning I had crank sensors turn up. So I got a brand new crank sensor for the job. So it's time to wire up the coils. I happen to have my spare test coil here off my 3UZ. And I've written the pin configurations on the top of it. So we've got the earth, goes to earth. We've got a 12 volt, which is the 12 volt input. And then we've got F and T. So F is for the feedback and T is for the trigger. Aftermarket ECU, I'm not using the F, I'm not using the feedback. But make sure you block up the hole, otherwise water can get in there into that connector. Okay? And it's actually, I should do it from looking at the pins. So when you number the pins, it's like this, pushed on here. So number 1 is the 12 volt. Number 2 is the feedback. Number 3 is the trigger. And number 4 is the earth. So here's the loom I prepared earlier. With them pushed in, make sure you clip the lock tab in the front. Moving along on this loom, I've done the coils on this side, which would be the left hand side. Right hand side is pretty much finished. It's taped in. I've still got to shrink it, shrink the shrink wrap. Coils are done. The loom runs along the back. Got a suppressor, radio suppressor for the coil power. And actually I don't really want it mounted up there, but there is a nice mounting point in the manifold. And at the moment the map sensor is also just poked in there just to get it out of my way. But that's going about where my camera is on the firewall. And I don't have a firewall because it's on the bench. Next is the earths. I'm just making up the earths at the moment. So when I make the earths, I will split them into 2. So they can go like this if you want. Or they can go like this. That'll work fine. I don't really mind as long as they are earthed and done up tight. I don't want them up onto there. But I'd like them nice onto the back of that head if possible, is the best spot. You notice also I've zip tied it, cable tied it up onto this fuel rail, getting it away from this crossover pipe, and I've pretty much left this crossover clear completely. The start trigger, that can come in behind as well. That can be tucked right up in behind. And that's going to join into this loop. So it keeps everything out of the way, neat and tidy. With the suppressor inside, you don't actually see a whole lot at the back here. I probably should put those reverse lights in too. Got to put the reverse lights coming out of here, and they're going to come down a bit off this engine. So I'm pretty happy with the progress at this point. Slow and steady wins this race. We certainly don't want to make a mistake because it's really hard to put a wire in later. And it's certainly a big improvement on what we started with. For the earthing circuit, I've run a separate earth to the 4 points on this extreme. So on the ECU, the bottom corner is earth points. When you're doing up a wiring job like this and you need diagrams or wiring information, it is available in PC-Link. We'll pop into the program now and have a bit of a look. So we open the PC-Link, help file is here, wiring information right there. And I'm actually just wanting the header, it's an extreme header. So you can see here is the ground in the corner of the A and B plug. So all the information that's required is contained in the software, as long as you've got a reasonable knowledge of sensors and how engines work. I've run an individual earth for each of the grounds on the link back to the back of the head, back of the cylinder head. And I've run a couple of extras. I'm running a wideband plug that I'll put inside the cabin. I've put an extra one in there for the dash plug, just if it's needed, and I'll probably put an extra one in for OBD2 if it's required. I've also put another one over to the relay box area, so it's all contained. You don't have to add extra earths in for your relays and fuses, it's all in the one. Also the coils have to be earthed to the back of the block. There's an individual earth for each side, so the left hand and right hand have their own earths to the back of the block for the coils. All the other sensors are earthed through the sensor earth or 0 volt from the ECU. So the sensors aren't earthed to the block directly, they are earthed through a regulated earth inside the ECU. Sometimes I do question some of the decisions that I make. On this loom, I decided I would run the power feeds off the front of the engine because there's a box on an IS200 at the front, on the front left hand side. So I'd make it like an IS200 engine which comes off the front, our Tesla engine, or a 3UZ engine. They all come off the left hand front. The old loom used to run off the back. We'll have a look here. So this is the old loom. I'll just try and decipher it again. Here it is here. So this went to the computer. And this bit of loom here does the big loop of the car. There's fuel pump wires popping out over the back. So that's like by the firewall. And this ran along the side of the car to the box on the front. Igniters were mounted there. And then these plug into the box. So I know why I did it, because I knew it was going to be neater, and it's a bit of a challenge. So I've brought the power wires through the loom, and it's going to jump straight off the loom, straight off the engine into the box. And yes, this is longer than it needs to be, but it can come down past the air conditioning pump up into the box just fine. Of course, shorter is not going to reach, but longer does still reach. So it's better to make them a little bit longer in this case. I don't have photos of that left-hand front of the engine bay, so I'm kind of guessing a little bit, but I'm pretty sure my guess is going to be pretty well right. I've also decided to make up a set of relays and fuses. They're all in this car, but I can see by the past wiring there are issues with the car, so I'm going to replace those issues and put a set of relays and fuses, just a real simple one, so I know that the engine is getting good power supplies. If I had the car here, I would do it differently. I would tap into the factory car, but I'd also be checking all that car for issues. And because we can't do that, this is going to be a simple way to overcome problems, and I know that this part of the car is going to run like it should. Probably should say I've actually completed. As you can see, I have actually done most of the left-hand side. So the loom runs along just like the right-hand side. Big gap, injectors popping out to make it nice and simple. And you can't get these wrong because, you know, this one goes to the back. That one won't actually reach on there. If you try to put it over there, it won't stretch over. So you can't get the firing order of the injectors wrong. And it'll still run. And then in the coils, the same deal. Like I can make this one fit here, but then this one won't fit there. So you can't get them wrong. Coming around the front with the cam sensor. If I wasn't running an aircon pump, I normally attach it down low. And I did remember this one does have an aircon pump and that just gets a little bit tight. So at the moment it's zip tied through these holes here, which are left over from the distributor cap not being in place. And then the cam sensor is going to tie up nice and high like this, so it won't rub on anything. Pin out for the cam sensor. So on the factory one, the red is the signal and the white is the earth. So pin 1, looking at the back of the plug here, pin 1 is the signal, pin 2 is the earth. And the same goes for the crank sensor. So I have a crank sensor here. Here's the plug. And I've written on it for you. So pin 1 is the signal, pin 2 is the earth. Looking at it, goes that way. This one's the coloured wire. Mine are white and white, but one of them has got a bit of a blue trace, which is the signal. So 1 is the signal, 2 is the earth. And if we actually look it down on the plug, I remember it as the one closest on the outside. Closest on the outside. The one on the outside of the engine is the signal. I would normally run my crankshaft position sensor wiring down through the back of here like this. Tuck it like that in the back of the engine. This particular car's got a hydraulic fan pump in it. I would like to see that pump gone and replaced with an idler. We'll see what an idler looks like, shall we? So the idlers look like this. They don't have any hoses coming off them and they're smaller. That'd be much neater on this car to tidy that whole section up. The other thing you'll see on this particular one is I've blanked off the water line on the top of the thermostat housing here, and the one on the side is blanked off as well. So there's no, and the one underneath, so there's no extra water housings. There's no just bolts pushed in with a bit of pipe stick on and a bolt stuck in it. That's pretty ugly. So that's neat and tidy and tidied up. Just been welded up. This one here was at the bottom, so that was welded. That one actually is off a Celsius, 20 series Celsius. And that's where a oil cooler outlet, water outlet would normally go if it was an LS400. With oil pressure, now I've made the oil pressure nice and long, so it can either come down to the sensor back here, or if it's got the sensor at the other side. And because there will be an air conditioning pump in it, they may have to come down through here like this. But it's long enough to come under here, do a bit of a loop around and back onto one under there. Just check it doesn't rub onto the crankshaft pulley. So neat and tidy. So there's plenty of options. Probably fit around here like this and it'll still be long enough with that other housing. Goes in about there like that. So plenty of ways. I've made it long enough. These are real simple sensors. Pin 1, pressure sensor, is 0 volts. 2 is 5 volts, and pin 3 at the bottom is the signal. So that's cool. My next mission is to finish up in this department. So that's going to sit there like that. Join some wires and into the ECU. So, back to work for me. I'm back under the disco lights, but I'm getting to the pointy end of the stick of this loom. Those are the power feeds that are going into the box under the bonnet. Main loom is sitting like so. I've done my joins. So now coils, this coil and this side coil and the suppressor are on one circuit, coming through a 16 gauge wire there. Injectors are on an 18 gauge wire there. I put a bit of sleeving down through here to where the computer is, and it's time to terminate at the ECU. One great thing about working from both ends of a loom, it means you can put the sleeving over nicely and really finish it off instead of having to work the whole thing from the ECU out. Pretty much as I go through, I will multimeter every single wire to double check that it goes to where it should do, terminate it, double check it at the ECU out. That way I know it's going to be right. There's also going to be a couple of connections by the ECU in this one for in the cabin, so those will be terminated up, along with a wideband plug. So in the future, the wideband controller can be plugged in, and I'll wire that all up to the ECU as well. So far, I've been connecting wires to the engine. I haven't actually had a wiring diagram. So it is time for me now to actually sit down and just write up my inputs and outputs properly. They are in my software, so I've got the laptop going. I'll use the blanking pins to blank up any ones that aren't used to retain some waterproofness. And we'll terminate some wires. Here we have the plugs all fitted, so those are the wires I'm using. I basically went through the program very quickly and just lined up the positions of things like the map sensor, which pretty much all go in the same place anyway, and the TPS. I know I had 8 injectors, so that's all the same. On a link, the later links, the injectors are numbered in cylinder order. So it's real simple. Number 1 injector drive goes to number 1 injector, number 2 to number 2, number 3 to number 3, so on. And the same with the coils. We only had 2 coils before, so number 1 went to the igniter that fired number 1, and number 2 went to the cylinder that fired the next cylinder in the sequence, 1, 8, so it followed number 8. Now I've got individual coils. I will then put them into cylinder order, 1 to number 1, number 2 to number 2. I will also have to change the trigger offset in this. I will talk about that later on. Presently on -4, but individual cylinders, individual coils will need a different offset. I put an output or an input for the wideband, and the extra thing I've added is a start trigger input, and that will allow changes to the cold start mapping. So you can put a pre-start prime on the start trigger if we want to. Doesn't mean we have to, that's if we want to. It's not turned on in the ECU. The cold start prime isn't even turned on to key on. I think what I'm going to do is I'll actually show a bit more of the connections of this. We've gone over the engine pretty basically, so I might as well spend a bit of time showing which wires go to what on the link itself. I'm sure there'll be some benefit for people who are wiring up a LINK ECU. And the information can apply to any engine. As long as you know how that engine works and what the sensors are, then it's pretty straightforward to wire them up. So I've put in a power and earth as an extra inside the cabin for the likes of if we want to wire up an OBD2 plug to run the OBD2 dongle. And that'll allow configuration or communication with a cell phone, smartphone. This is a shit one, it doesn't work. Don't get one of these ones. The Extreme had 2 different pinouts, depending which version it is. One of them had a CAN channel in the header plug of the ECU. This one doesn't, it's an early one. I've checked the PCB board number, or the version. And so it has to go through the CAN plug. It's located beside the tuning plug. So it's down in here. So it does have the ability to have CAN output. That isn't allowed for in this wiring job, but it can simply be made later on if the customer wants to communicate with a cell phone. But they have engine temp, throttle position, checking fault codes. So you don't have to use the laptop. You can use your phone and actually clear fault codes with your phone. So it's quite a handy feature, and it does allow a normal scan tool to be plugged in as well. So don't need a laptop as such to clear fault codes. Call into a garage with an OBD2 scan tool and you can clear fault codes. So it's quite a neat feature. That's for another day. So let's get into it. Let's have a bit of a look over my scribbles. This isn't going to come up very nicely, but basically I've just gone through and identified which cylinders go, which bits go where, what I'm using. I've identified my outputs, my grounds. Grounds are in the corner. Labelled up my knock sensors, and anything I'm not using, I put a plug in at this stage. As you can see there. I've sized up, and I'm actually going to be just ever so slightly longer than it was. Again, that same principle, it's a little better to be a little bit longer than too short, because too short won't reach, but too long will. So let's pick up some wires. Hope you guys are paying attention. One of the things I'm quite aware of is I do tend to talk quite fast. Maybe you guys just listen too slow. Something to think about. I'll try to speak a bit slower. Let's connect some wires. I've had a bit of a sort out. So here we have some wires in my disco light workshop. It's not actually disco lights, it's just that the camera picks up disco lights. I've got some earth wires. So these are sensor earth wires. They come back to the ECU. I'm going to run them all to the A plug. There's only 5 of them. Oh, yes, there's 5. So we've got oil pressure sensor, map sensor, EFI temp sensor, water temp, throttle position sensor, and air temp sensor. So that's those. We've got 3 5-volt going to different sensors, oil pressure sensor, map sensor, throttle position sensor. So that's nice and simple. We're going to do them later. I've got 3 multi-core wires here. Cam sensor, crank sensor, and knock sensor. I have 8 injector and 8 ignition. And you'll notice they're yellow and greens. There's actually different sizes in here which you won't be able to see. But you see that's a 22 gauge and that's a 20 gauge. So that's an injector and that's a coil, because the coils have got built-in igniters. You only need a little wire to trigger them. In here I have 4 earths. So plenty of earthing. I have a power feed, and that will be split, and it will go to both the A and B plug. Got an idle speed control. That's a grey wire. I've got TPS wires. So there's a throttle. There's a TPS and an idle switch wire. There's a map sensor wire. There's an oil pressure wire. There's a water temp, EFI temp, and an air temp. And that leaves 5 wires here. Now for the auxiliary outputs. So we've got fuel pump, fan, and tacho, which are under the engine bay. And I've got 2 more. One of them I intend for oil pressure under the bonnet. And the other one I intend for an engine check light under the bonnet, because it would be nice to get that going. Over here I have a water temp for the gauge. I've got a spare wire which is actually going to go in the other loom. That's going to become a start wire. I've made a little bit of a change. So that wire is going to be start, and that will be start trigger to the ECU. That's why I put a spare one in there. So I've got water temp. I've got the possibility of an alternator light coming into the cabin, which is like a spare wire. I've got lots of earths. So one for the dash plug, if we just as an extra. Two for the wideband unit with a power supply. And then I'm going to put in like a power supply for like an OBD2 if we put it in it, and just an extra earth power supply for generic if you like doing test equipment or something like that. So that loom isn't getting touched at the moment, don't need to worry about that one. And there will be some more wires going this from the ECU. There will be some extra outputs from the ECU yet to go into there. To start this process, I'm going to do the earths. Nice and simple. So make sure you have the tabs popped up on these plugs and make sure they go all the way home. As I was saying, make sure you put the tabs up. Oh. Also, what I'm going to do is I'll label them A and B. Here we go. Just makes it a bit easier. I've connected my multimeter into number 1, injector. Injector's at the top, number 1. Injector right there. Push it all the way home. Going to pop over to number 2. Though you can't see it, there are different sized wires in here. So it's very, very easy for me and very quick to find each wire. And pop them into that ECU. 1, 2, 3, 4. Some might think I'm crazy running the multimeter across all the wires and doing it this way. What I find is it means that I double check all my connectors, that they are all good. And you always check the last wire. Because if the last wire doesn't pass, then you've got a problem elsewhere. And then I do exactly the same on the ignition circuit. Number 1. And as I said earlier, they are wired in cylinder number, not firing order. Some of the older ECUs, you'd wire them in their firing order because the ECU didn't correct for it. But it's more common these days to see it wired in cylinder order. So 1 to 1, 2 to 2, etc., etc. So that's a lot of the B plug actually finished. Needs to be a power, wideband, and knock to go into there. That's pretty simple. Right, we'll continue on with the other sensors. So that's ignition done. Right, it's the same deal with these. Now most of these are different colours. So I go through and I strip and I crimp. Let's pop a few of these accessories in. Now I think I was doing oil pressure. My tool is down in the oil pressure. And it should be brown. One, two, three, four, five. So that oil pressure is going into an analog volt. I have actually already popped the TPS wire in. So that went into AN volt 1. So that's the 0 to 5 volt signal back from the TPS. And the oil pressure is a 0 to 5 volt signal from this pressure sensor. I use a lot of these. They're real simple and they're nice to use. I'll set up a calibration for it. The pinout's real simple. So 0 volt in pin 1. Pin 2 is the 5 volt and pin 3 is the signal return. So I use, as I said, I use a lot of them, real nice, and the calibrations are nice and easy. 0.5 of a volt is no pressure, and if they rated it 100, 150, 4.5 is the full rating. And then we do our map sensor. Map sensor was a straight white. And I will actually pop in and just double check it, even though it's the only white wire in the loom. Same principle, I want to know that it's right. And this will go into AN volt 3. Next I'm putting in the idle switch for the TPS. So with the idle switch, it doesn't strictly need to be in there, but it is nice to monitor when the throttle's completely closed, and then you set it up like a factory TPS. If you did want to change an idle target or change something at idle, then it does allow you to do that. Same as the start input, which I'll do now. It's the only blue wire, so I know it's there. It's going to be this one. VI3. With the EFI temp sensor, polarity isn't important, so it's got an earth or a 0 volt back to the ECU and the signal. And that will be temp 1. Temp 2 is going to be air temp. Air temp and temp 2. idle speed unit is going to one of the auxiliaries. On this loom I have 5 wires going out to the fuse box area. 4 auxiliaries. There's fan, fuel pump, there is tacho, fan, fuel pump and tacho. And then I've actually put in a couple of spares as well. I would like to see an engine check light in this vehicle. So I've put that out there. And I've also put out one for oil pressure, which I'm hoping that oil pressure will be controlled by the ECU, the light on the dash. I'll also put a couple inside the cabin. And if necessary, they could be swapped over really easy if you don't use them under the bonnet. If they're not used in the engine bay, in that connector, they can be used inside the cabin. If you want to move them around, they just pull in and out once you pop the pins, once you pop the locks. Just adjust this. So that's the main part of the wiring done in that sense, in that bit. I've got left power feeds, so they're nice and simple. The earths and the 5 volt to go, and a couple of auxiliaries to the dash. And this plug is the knock sensors, a power feed, and the wideband connectors. I'm going to put the 0 volt join, or the sensor earth join, just slightly out of the loom, so it'll just pop out so it can be seen. I can tuck them into the loom as well, but in this case I think it'll be, I don't mind seeing them, and it gets them away from interference with everything else in the loom. And the same deal, we're going to check those earths, go to all the correct places. So we have it at oil pressure sensor. It'll work better if the multimeter is on. So yes, map sensor. Water temp. TPS. There it goes, and air temp. So that's our 5 earths. 1, 2, 3, 4, 5. Yes, 5 0 volt. Oh, hello, miss. How are you? G'day. With the 5 volt supply, we're also going to check all those sensors. So this time, oil pressure, throttle position sensor, and map sensor. In this loom, they're all the pink wires, so that's nice and simple. And the 0 volts are the black orange wires. I've had a bit of a relocation of my wiring in here, and just a bit of a sort out. moved off the knock sensor wiring, which goes to the B plug. And I've got my my cam and crank sensor wire going to the A plug. The 0 volt or sensor earth goes into the ground out pin, and the 5 volt for the TPS map sensor and pressure sensor goes into the 5 volt output. Well, it's just listed as +5. So that's done. And I've run the extra auxiliary outputs out into my dash loom as well. So they're all done, along with the wideband wires. And I ran an sensor earth, depending on which wideband you get, whether they want a sensor earth. And then there is 2 analog volts. So one would be the wideband, one would be a narrow band. You're only going to be using the wideband normally, but it means you don't have to worry about terminating up wires in the wideband, or having spare wires. They can go into a plug. They actually go somewhere. What you may not have noticed also is I've left a couple of wires in here unterminated, and they're my reference length. So this one happens to be, I'm using the 12 volt supply, and I've cut it off. It's ready to go in as such, but I use that for the length of all my wires. So all my wires end up pretty much the right length, and that's how I reference them off. The shielding wire I'm using, so that's a Tefsel wire. I'm using a 20 gauge. You can also use a 22, and I'm using a 2-core. So I've used that for the knock sensor, the cam sensor, and the crank sensor. And you peel back the outer insulation, you've got your shielding inside, and then you've got an earth wire and the signal wire. So trig 1 is the engine speed. So that's going to be your crank sensor. Trig 2, of course, is going to be the cam sensor, or it's the sync or the position. I always use the left-hand sensor. Okay, so it's on the same side as the crank sensor. The shield and the signal wire will go into the shield ground terminal of the link. The sensor, of course, goes into each of the trigger wires, the respective trigger wire. The shield should not be grounded at the other end. It should be left open. Otherwise, you can get yourself some pretty major interference issues. So the shield is only grounded at the ECU. So I'm going to pop in and do those couple of bits and pieces now. And I will show you the joining up. I'm going to take the insulation off, join onto the shield, and make all this work. So I'm just going to do a bit of prep work, and I'll come back to you on that. So in here I've joined the sensor earths together and the shield grounds together in a very small crimp right there. And be very, very careful not to get any stray wires. I'm going to shrink all that. And now these can be terminated into the ECU. And so can the 12 volt feed, which goes in on the 14 volt. Like all the other wires, I am going to check it And it should be pin 2 for the earth. Those are both fine. Pin 1 on the crank sensor. I think I'm on the cam. So that's my crank or speed sensor. Trig 1. Let's go to trig 2. Ah, that's my finger. Oh. And now I repeat that same process, kind of similar, with the knock sensor, but it won't have a ground wire. It'll have the shield wire, which will go into the shielding. That's kind of looking as I would expect it to look. Let me do this knock sensor and we will finish off that little bit that goes to the ECU. For the knock sensor, I've moved off the shield and I've just crimped onto a piece of 20 gauge wiring. If you want a really little crimp, what I do is I cut down the link terminals. I cut off the piece that normally goes onto the insulation and the terminal itself, and you're left with the little crimping part. And I shrink wrap the join. I'll just wait a minute for that to go off. Let's go hard. And then another bit of shrink wrap over the whole lot like that. In the second plug, I always put the 14 volt in. I believe it's only for the power feeds for auxiliary 9 and 10 for the drive-by wire. But on some of them, at one point, they used to bring up a fault code if there was no power to that plug. So I just do it as a matter of course. Earth into the ground output, shield ground output. Right hand's got the blue. Left hand is number 1. I'm putting the left hand on number 1 because that relates to number 1 cylinder. Put the locks in. And they should just push in nicely. If they don't push in nicely, there's a chance that one of your pins isn't in properly. So that's sitting as I expect it. These zip ties here are going to stay. And that can be popped back, the shield grounds can be popped back in there like that, which I think I probably will do on this one. So this is at the point where I say we need to tidy up. Some guys, they say it needs a tidy up and it's a big bird's nest. By that stage it's probably a bit late. And we'll put this back over. I've now done all the plugs from the engine loom onto the body, onto the car. With a job like this, I had a sort of a rough idea what I was doing in my head. I take some time to consider what the car's like and the best way to fix it. Which means sometimes we do things a little bit differently, just because we're doing it remotely and it solves problems from people in the past. And this car is battling that problem. Coming up by the ECU. So I've fitted up the braid. And I've put a little bit of extra braid, just if it goes through a firewall or anything, just to extra protection. And through here, it's double sleeved anyway. Comes up. I haven't shrunk this piece of shrink wrap. It's pretty much just holding the wiring, the braid in place. And that's so if you do need to repair in here, you can take it apart quite easily. Got the 2 ECU plugs. I've got the 6-pin plug, the DTM plug, and I've written on it what they are, and that's for the wideband, if it ever gets a wideband in it, which is what I prefer. I prefer to use a wideband. This has got a 12 volt and a couple of earths for hooking in test equipment and stuff like that, or if an OBD2 plug was fitted up. And then this is for the dash. We've got a water temp here. We've got an earth. I've got a spare wire, and that spare wire comes through to here, under the engine bay. We've got the alternator light wire and a couple of auxiliaries from the ECU. And that's auxiliary 7 and 8, the bottom corner of the ECU. Over in this department, I've done a plug with the big power feeds through a DT plug. Again, I've labelled what they are. I've made a little alternator loom coming through. Again, labelled what they are. Now looking at the alternator, I've used a sort of factory colour. So white is generally the sense wire. That's in pin 3. Ignition is pink. That's in pin 2. And pin 1 is the light. So light, ignition and sense. Very simple on these alternators to wire up. So I've run that, and I've just run it along the bottom of the engine. Shane, the mechanic, can pop some studs. I normally take the bolts out of the bottom of the sump, put a stud in, and then attach them nicely along the bottom of the engine. As per normal, when I was connecting those wires up, I was multimetering. Multimetering, is that a real word? Checking for continuity through all the wires that needed to have power at them, so I know that it's right. My goal is once you put it together, you just hit the go button and it up and runs. Of course, certainly that for the customer. When I do it, there are ways, and I'm going to show you on this one how to test circuits. So we'll do an injector test and a coil test. I might put them on a separate video. And that way, you know it's bang on. If we're doing it this way, generally I just hit the go button and away they go. Because I've already done the testing on the bench, and then doing an injector test would be a second, third test. Next, I'm going to build up a little set of relays and some fuses to go in the box under the bonnet. And that's just going to take care of better power feeds to everything. As we remember, it was run off one wire. So the injectors, coils, and computer, idle speed control were all off the one wire. And I really think that's insufficient. This car's had a history of running issues, and poor power feeds can cause that, and poor earths. And the earths on this engine were crap. So we improved earths, we improved power feeds, new wiring, new ignition system. We should get somewhere, and it should go really well. So I'm going to build up the relays and fuses. I'm going to check I'm going to check all these wires. Same deal, I'll multimeter them all as they go into a plug. And I'll start on those relays and fuses. Made up some relays and fuses. So this is a really simple set of relays and fuses. just to supply power to the coils and injectors, and the ECU. So each of those have got their own relay, and one for the wideband that will only come on when the fuel pump works. I've used a set of fuses up through the bottom, so the terminals up through underneath, and mini relays. So nice and simple there. I fitted the 2 factory plugs that'll plug into the vehicle, and I've put this extra plug on which has got a fuel pump output, fan output, and a tacho output, check engine, and an oil light. They were just coming out randomly. There. There's one somewhere else over here. I put them in this plug so that plug can be pulled apart or changed, or it can just be pulled right back to their source over in this plug over here. The ECU is now plugged in, and we're going to look firing this engine up. Now I've got all the wiring done, I'm actually going to call it quits on this part of the video. This was a pretty basic process of running through it. I will be doing another couple of videos on the setup. Instead of tacking them all in the one, I'm going to separate setting up. I'm going to actually come back to you in a few moments with the engine running. The setup I'm going to do in separate videos, and I'm going to break it down into each individual part of the setup, because I think that's going to be a lot more helpful for a lot of people. I know it's a G4, not a G4 Plus, so it's an older platform, but the process is exactly the same. So we're going to make a couple of little videos just on the setup, getting it ready to fire up. We'll come back when it's running, and I'll just do a real brief run through for you. So I'll talk to you again in just a moment. With all the wiring done, and with the setup all done of the ECU, I fired it up yesterday, and that's shown in one of the setup videos. But I've come back in for a cold start this morning. Didn't even bring my laptop, so let's have a look at it and see how it starts this morning. I've got the throttle body fitted back on. It's got a different air temp sensor, so I've made a little adapter. Well, I've just jabbed some wires into there so the air temp works. Map sensor is mounted nicely on the top of the engine, as you can see, with it's the gravity mounting, just sits there. I've tied up the reverse wires because there's a spinning thing here and I don't want to cause issues. I haven't shrunk the shrink wrap yet. I do that once it's all running. ECU's here. And then they've got the wideband wires, some accessory wires, and then a couple of extra wires for the dash. The alternator only tension is fitted just for this case, just so I've got an alternator charging. And it does charge, I checked it yesterday. Wiring, cable tied out of the way. Deutsch plugs there, relays and fuses. Here's the bag of goodies. Now I did actually wire the alternator light that was in this vehicle. I think it's dumb. I'd like it to go to the dash, but for the time being and for testing, it's quite good for me in this situation. So let's see if I've got enough juice in this battery. So that's not too bad for a cold start. It'll need some tuning once it goes in the car. It'll need some tuning once it goes into the vehicle, but at least now it can be set up properly. And it can get some cold start prime on the start function and a few other bits and pieces like that, and actually be set up properly. So I think that's a really big step forward. If it had a wideband fitted, it'd make road tuning much easier and setting up and finishing it up on the road. But so far I'm pretty happy. I've got a bit more finishing to do, and then I'll pack it up, put it in a box, and it can go home to its customer. Shane's Looms instructions. Hey, g'day guys, going from the Car Tune Company. It's a wet day here, and my tin shed's going to sound like a tin shed, so there's going to be a bit of background noise for this video. But I'm on a bit of a time frame, so we're just going to have to roll with what we've got. And I did a little teaser video on this loom the other day to show the customer where I was at, and I thought I'd better do a proper set of instruction videos on how to wire it, how to do some testing. It's going to be a bit weird because I'm going to do a fitting instruction backwards, because I'm going to be taking it apart. I'm also going to do, how to test it, how to set it up properly. So let's get in and get straight into it and see what we've got, and I'll show what goes into the box as well. So sitting on the top of the engine here we have 3/4 or 19mm, it's actually 3/4 frost plug. So that's for the cold start blank. So that'll be pushed up into the bottom of the intake manifold. You can just smack it in there when you take the cold start injector out. And there is an 8x1 threaded bolt, and there's a washer on there, so you can cut that to length and put it all together. So that's going to go in the little bag of stuff over here. In the bag's also the old crank sensor. There is that piece that used to have a bit of rubber in it, I believe, to go into the box, and a pair of second-hand knock sensors. Here is the idler unit. So when you strip it apart, really simple. That'll just bolt straight on, and that will allow the wiring to slip in through the back for the crank sensor. So nice and simple. Straight bolt on, no problems there at all. We've also got a set of lower insulators for the injectors, the cushion, and the top seals. There's 10 seals in there. Make sure you put a bit of lube. Don't try going in dry, they will pinch. So that's going to go in your box. The relay and fuse up box is all separate like this. We're going to connect in some power. And we have 3 plugs coming off the engine loom. So one is for the alternator, so that is its own loom. So that will be separate. There's a 12 pin and a 6 pin. They're marked up with what's going through there. And we'll simply just plug in. I do have the light for the alternator light. I do want that actually run inside properly on the dash, but I did put it into this plug, but it does go right through and it pops out in here at alternator, alt. There's also another wire in here called spare. So that spare wire is located in this pin as spare. I better get the pin. Oh, there's some extra pins in that 6 pin. I'll put an extra pin in there for you. So if you want to run something else through there, such as the aircon trigger to the ECU, and then it's long enough You can actually change it around and pop it into the ECU if needed. There's also some documentation, the pinouts, my hand scribbles, the pinouts of these two plugs for you, and what goes on in there. So at the moment I'm just going to use this. As I said, I do want it put onto the dash. I'm going to put permanent battery power into this white wire. That's listed under here as S. That's for sense, which is the sense to the alternator. That's the power, the permanent battery power over here at the alternator. So that's pin 3 of the alternator. Pin 1 is the light, and pin 2 is the ignition. So once you've plugged the relays and fuses in, we need permanent battery power to this plug here. So it's the big white plug, and it's got white wires. I've supplied the plug, so there's the plug going in the bag. That's permanent battery power, hopefully from a main fuse. And then just plug these two plugs here in. At that point you should have, at this white wire, permanent battery power. And I'm just using a test light, just a normal bulb test light. And at the alternator, permanent battery power. The next thing you should have, there's this white red wire. There should be ignition, and I'm going to have to give it ignition because I don't have a car. So there should be ignition at that white red wire. We see the battery light comes on, and at pin number 2 there is ignition, and pin number 1 of that alternator, if I actually top into there, you see my bulb glows, but it isn't as bright, but it makes the alternator bulb glow just very dimly. So that's a good sign. At this point we should have power to most of our stuff on our engine. You'll see the top covers, I've cut them just behind where it skinnies, so just on that right angle there, on that corner, I just cut straight across. And just be careful that you don't catch wires when you put it on, and they will need spacers underneath there of some sort. Take that cover off. So at this point I have power to my coils, and I'll have power to my injectors as well. So the next wires that you need to connect, of course we'll go over the fitting the loom in a moment. So we had 3 wires coming off this fantastic loom that are important. We actually had a couple that weren't important. So we had these 2 here on this plug. We had a green one and a white one, or white red, into that plug. That was for the oxygen sensor, not required. Right beside that, there's one that comes off that was a orange black. That was for the fuel pump trigger. So that wire connected into here. It's an orange white now, and it's called FP. That will give you a negative output when the fuel pump is on. I can actually click it with my test light there, and it is turning on this relay here, which is also the wideband relay. So I want it, so the wideband is also powered only when the fuel pump is on. So that is that plug inside by the ECU. If I actually swap my over to there, so I've now put my test light onto the positive side. We'll just and I'll just power this up. You'll see it's nice and bright and it'll switch off. We'll do that again. So that's the fuel pump circuit. So that was the orange black wire. It'll be up by the fuse box at the back of the engine bay. The next wire to connect. Okay, so over by the front box, there's two more wires here. So one of them here, we have this one which is orange brown. That is the fan output. So orange brown is fan. On this plug here, it's brown orange and it's got fan. So connect that into the fan. And then we have this one that says not the fan, auxiliary 3. That is your tacho. And that was orange red. On this plug, its happens to be a purple white, but it's got marked tacho. Also in this plug, I have an oil light output. Same deal, that will be an earth when it doesn't have oil pressure. And when it does have oil pressure, that'll switch off. So if you find the oil light, and it'll be by the box under the bonnet, that'll work. And I've got a check engine light as output as well. So you can power those up. Inside by the cabin, by this ECU, I have that alternator light coming through. I have auxiliary 7 and 8 that go to the ECU. I have H2O, the water temp sensor. So the H2O water temp sensor goes to the single pin sensor on the engine. So it comes through the loom, comes out inside the cabin for you. So you can go to the aftermarket gauge that's in there. And the reason it's got an aftermarket gauge is the temp gauge on an Altezza or IS200 is on the multiplex. And this link doesn't communicate with that multiplex. A plug-in link does. And we have this spare wire. Oh, we have an earth in the middle, black wire. And we have a spare for anything else that you want to run from out there to in here. With this test light, marks on the fuse box, alternator, accessory. So that accessory power is there's a little plug inside here for later on OBD2 plug or anything else or tuning gear. There's power and 2 earth wires on that 3-pin plug by the ECU. Alternator is the ignition source to the alternator. Injection, coil, idle speed control unit. ECU and STA start. And so that'll only happen when you crank it. Did we get it? Did it go? Try again. So that's all fine. With the engine, it's designed so the shrink wrap will zip tie, or if you want to make brackets, onto the fuel rail bolt holes. The coils They just slip in, and I've got these little sticky things if you want to secure the wires beside the coils. Idle speed control unit, so really easy, comes with the whole block, pretty much just bolts on, plugs in, nice and simple, and feed air into it. The crank sensor has got it's got some red writing for S written on it, and same as the cam sensor, so I'll be pulling that apart soon and popping that in the box for you. The water temp sensor will be in the box. Around the back of the engine, there's a orange and a purple wire. They will come down to the reverse lights on the gearbox, and there is going to be a start loom in the box, so I'll pop that apart in a minute. The wiring loom kind of made it go up, stay away from the water fittings, and it can cable tie up into that fuel rail, the fuel line coming through the back of the engine. If you want it to go down the bottom, it still will reach. The noise suppressor, I would mount it in the middle of the plenum, and the map sensor up on the firewall like the old one. So that's pretty straightforward, nice and simple. I've got my laptop attached here. Oh, wideband. So I would like at some point, hopefully a wideband unit go in. There's a 12 volt, as explained before, that's off the fuel pump. It's off its own relay, but it only will have power when the fuel pump is going. So it'll prime, and then it'll go once the vehicle is running. And then there is auxiliary, no, there's AN volt 6 and 8, and a 0 volt from the ECU, which depending on the wideband, you may or may not need that. And you can feed in a narrow band and a wideband if you want. And I have supplied the other side of that plug for fitting up a wideband. So I've got the laptop attached, and we're going to have a bit of a look at setting up the idle speed. So a bit of a note when you're doing the idle speed. What I normally do is I set a base idle with an aftermarket computer. So I warm it up, and I pop the throttle body stop off, and I just bring the idle speed up till I get about a 700, 750 idle speed, and I'll give it 100 or 150 idle above that. So whatever you want your idle at, you set the base idle 100 to 150 less. Don't use the throttle stop on the top. It's the one on the bottom. Now you may get away with standard settings on the throttle body, which, hey, that's great. I do like them left standard if you can, especially with standard ECU, but it's a little bit different with an aftermarket ECU, so it's not unusual to adjust that base idle. This one is stock standard. So let's see what sort of idle I can give it to try and put some numbers that are pretty close in it. Oh, what about this? Oil pressure. There's your oil pressure sensor. So that can be popped into the factory spot, and the wiring loom's good for either of them. Crank sensor, I do, as I said, you can see it here, down and behind that bracket. Check it doesn't touch on that crank pulley. So here we are in the G4 software. Connect to ECU. So I've got some settings that are reasonable here. I've got some idle speeds. It's a little bit higher than I will normally like at 900, but it's a good place to start. You can adjust it down once it's happening, once it's going. And at the same time, I'm just going to go up here, bring up the runtime values, and have the auxiliary outputs. I've got it on closed loop at the moment. Just put these on, give it some fuel. Of course, your car, the fuel pump, should work fine. Let's make it go. here, and you can see the idle position is at 26, the target is 1200, and it's actually on the target RPM. So what we do is, as this comes up, we just adjust this right in the middle to match with that number down there. That's looking lovely. Just going to have a look at that cold start for you. Let's do the cold start. Turn that off. Whew. Yeah, cold start was shit, wasn't it? So what we've got here is starts at 10% extra fuel. As it warms up, it's dropping down, and at 70 degrees, it goes back up to 10%. So that is just shite. So what I'm going to do is I'm going to grab someone else's. Here's one I did the other day, and it was reasonable. So I put some new cold start numbers in it. We'll give it some fuel. And see if she starts better. Oh, that's better. We'll see if it revs better. That sounds pretty good to me. The idle speed might be a bit high, but that can be adjusted down quite easily now. And it is working fine on the standard throttle body, so just leave it standard, set the throttle position sensor. The side of the engine prep that needs to be done, we'll have a look at the throttle body for a start. So I've mounted my air temp sensor in the back of the throttle body. Now I know you've got a different air temp sensor, so that should fit in just fine. I drilled and tapped in here and put a fitting in for my air feed. So that's pretty straightforward. Water lines. Water line up in here. Welded. Gone. Any on the side or down the bottom, but they've just got bolts. I think your one's got a bolt sticking out here. Gone. I'll show you the covers. I'll show you what I've done to the crank sensors under here. Earths. Back of the cylinder head. Either there and there, or there and there. I don't care. Not up in here. There and there, or there and there. Yep. Sometimes it's awkward to get to, but just got to deal with it. Once it's all installed, I would like to see the base timing set. You'll set up the idle. Cold start isn't that important until you have a tune in it that's really good, okay? Because the cold start is a percentage of your main tuning map. So close enough is good enough on cold start until the main map is tuned properly. And the tune looks okay. It doesn't look too bad in there. But it might need some tweaks now. We've got some better spark happening and other things working better. So I would recommend some tuning time. I'd recommend a wideband so you can just do it, go for a drive down the road and see what it's like. Cold start, you can just tweak the numbers a little bit to suit. And as I've said, if you can set up a Holley carburetor by ear, you can set up a computer by ear. For the cold start, just a couple of revs, lean it out until it bogs a little bit and richen it up. And you'll get it pretty close. I've got a fair bit of faith in you, Shane, to do that, so you should be fine. I've calibrated the map sensor, and you will need to calibrate your throttle position sensor. It's in the settings, pretty easy to do. There's another video coming on doing that stuff. And that will ensure your idle speed works properly and your acceleration enrichment works properly. I've turned on the injector deceleration. So on decel, the injectors will now switch off, which they weren't before, they were staying on. And basically had a bit of a look through it. I might even turn on some logging as well, so we can, if we need a log file, you can send it to me. I'm going to start pulling this thing to bits. I'll show a few bits and pieces as it comes apart, and then we'll put it in a box and label it up, ready to come home. So let's get this loom off this engine. A few other bits and pieces I've done, just on the edge of the fuel rails. I often round the edges off, just get a file out. You notice all the distributors, all the bracketry for the distributor has also been cut out. So that's all I've got left. So that's how I've cut that one down, and I've done the other side as well. And of course it's just your sensor coming back, Shane. Ooh, that's hot. Oh, that's quite warm. And brand new crank sensor. That's the one that was run with this engine. There's the 2-wire forward idle speed control unit and bracket. The one that was run again with this engine. One wiring loop. And I'm going to pop the manifold off because there's a start loom in there as well to do. You see I tucked it actually in front of the crossover pipe. Right, let's get an intake manifold off. And there's the start knock loom. Right, I've got a loom off an engine. Time to wrap it all up and pop it in the box.
There you go, Kelvin. All done. Running perfectly. Kelvin of the Car Tune Company, New Zealand. Made a new custom loom for this IS200 Lexus. Running very good. A couple of little things still got to fix on it. Make a bracket up for the fuse box there and relays. I made some brackets up to hold the cores in there, as you see. Just a quick video to show you it's all running, mate. Thanks very much. Great job.